Okay, welcome to the fourth part of the lecture, and in this one we'll try to solve another example. Now this example is very simple. It says like consider two identical charged balls hanging from the ceiling by strings of equal length, L equal 1.5 meter, in equilibrium. So these two balls are in equilibrium situation. Each ball has a charge of 25 micro coulomb. The balls hang at an angle given as 25 degrees. So this angle here is 25 degree, and the same thing here. This one is 25. Why? Because they are identical. And because of that we have what we call like symmetry. Now what is the mass of the balls? So the question here, we have all of the information that we need in order to find the mass of these two balls, which make them reach to this static equilibrium. What's the mean static equilibrium? Means like these two are fixed, they are not moving, and that's the equilibrium condition or situation that we are trying to apply. Now we know that if we talk about an object under static equilibrium, it means like F net acting on that object, F net should equal what? 0. Now since we have here what? M1 and this is M2, and they are by the way identical, so M1 equal M2, so I will call this one M. So I will drop the 1 and 2 and just treat this one. And since we are dealing with identical situation and we have the symmetry here, whatever I do for this mass will be the same as this one. So I don't even need to solve these two objects. One of them will be enough because the other one will be exactly the same parameters and will have exactly the same quantity. So one of them will be enough. So I will try to apply this static equilibrium condition, and in order to apply this one I need to see like what are the forces exerted on each ball. As I said, like we'll only focus on one of them. Now in this case, all what I have to do here, I need to identify these forces. The first one here, we know like this is mg. There's a gravitational force that is always exerted on such system here, and it's always pointing down. So the gravitational force always pointing down, and we know that the gravitational force, if we are close to the earth, to the surface of the earth, can be calculated as mg. Now there's another force that is coming from the string, and I will call this one the tension. So the string actually is pushing the mass along with the string, as you can see here. So these two forces. Now there is also another force, because this one is a charged ball, as you can see, the charged ball, and they're identical. They could be positive or negative, but here they are given as like positive charge. So this is positive and this one is positive. And we know like if we have like two positive charge, what kind of interaction we expect to have? It will be a repulsive force. So these two charge are pushing each other away, and that's why they have this angle, as you can see here. So this force is a repulsive force. In which direction this force? As you can see, the line that is connecting between this positive charge and the other one is horizontal, and since this is a repulsive force, we expect that the electrostatic force is given. I will use the EFE as a way to describe it, electrostatic force. So now we have here what? Three forces. Now FE and mg and T, these three forces, when you sum them together, the result will be what? 0. So we can say that F net should equal what? 0, in such a way that the gravitational force plus the tension plus FE should all cancel each other in such a way that the net force should be what? 0. This is the equilibrium condition that we are trying to satisfy. Now, how can we solve this one? This is what we call like vector equation. Now, in order to solve it, I need to analyze each force as x component and y component. The good news about this question here, FE is already in the horizontal direction, so it has only what we call x component, and mg is also vertical, so it has only y component. The only one that has two components is what? It's t, which means like I can analyze it as vertical component, this is ty, and horizontal component, this is tx. And keep in mind that the tx and fe, they will cancel each other, and ty and mg, they will cancel each other. So the y component vectors, they will cancel each other, and the x component vectors will cancel each other. And that's why we end up with what? Equilibrium condition in such a way that f net will be 0. I hope you understand this. Now, all what you have to do here, we just need to analyze the vectors. We know that ty minus mg should equal what? 0. Now, why ty is positive? Because it's pointing up. Mg is negative, that's why it's pointing down, that's why it has a negative sign. And why it's equal 0? Because these are, we know that f net y should equal 0, so it means like ty minus mg should sum to 0. Agree about this? In such a way that ty equal mg. Now, what's ty? Ty is very straightforward. This angle here, theta, is the same as this angle theta. So I can analyze the t as what? As t cosine theta, because this angle is measured with respect to the what? To the vertical axis, and that's why the y component will take the cosine in this case. So that's will give me here what? T cosine theta equal mg. So this is the first equation. Now keep in mind, what's my target is to find m. Can I find m from this equation? Unfortunately, no. Why? Because we don't know t. So we have two unknowns in one equation, and because of that, I am unable to solve it. I need another equation, and the other equation, we can get it from what? From the y component, that f net, sorry, from the x component. F net x should equal what? 0. Now, what's f net x? It should be t minus tx. Now, why minus tx? Because look at this one. The tx is pointing what? To the left, and that's why it has a minus sign, plus the magnitude of fe, which is, by the way, you can think about this one as, forget about this one, okay, and that will give me here what? Fe, and that should equal 0. Now, in this case, we know that fe should equal what? Tx. Now, what's tx? According to the figure here, if you look at the t, it's pointing in this direction. The x component will be what here? Since this angle is with respect to the vertical axis, then the tx will take what? The sine. So in this case, we can define this one as what? T sine theta. So fe equal t sine theta. Now the question is, what's fe? Fe, according to the Coulomb's law, it's equal k q1 times q2 divided by what? R squared. If you want to apply this to this case, we know like the two poles, they are identical, so it will be what? Q squared, and q is given. Now R squared is the distance between these two poles. Is the distance here given directly? Actually, it's not given directly. We know that this length L, we know this theta here. I can find this distance, which is half the way, and if I call this distance from here to here as d or r, whatever you want to call it here, so I can find half of this one as r over 2 or d over 2, whatever you want to call it. So in this case, let me explain this again. The distance between the two balls is this one, r. I can call this one d, whatever. Now, half of the distance here, r over 2, can be identified as what? Using the triangle equation, this distance. Now, we know like this, theta is given, L is given, so r over 2 equal what? L sine theta. Agree about this? So in this case, I can describe this one as what? K q square over L, so not, yeah, L sine theta, but that's equal what here? R over 2. So R will equal what here? R equal 2L sine theta. So that's why I have to put here what? 2, and don't forget that we have what? Square from the formula. So FE actually will equal what? K q square divided by 4L square sine square theta. And that's equal what? T sine theta. But this is the second equation. This is equation number 2. And the first equation, if you remember, it was mg equal t cosine theta. That's equation number 1. Now, again, what's the target? The target is to find m. So in order to find m, I need to get rid of the t here. How can I get rid of the t? If I divide these two equations over each other, the t will cancel out. And that will give me here what? Let's use different color here. So it will be k q square over 4L square sine square theta. Here, m g. Actually, this one will be mg. That's equal what? Tan theta. Given that t with t cancel out, sine over cosine, that will give me tan. And according to that, m can be equal kq square divided by g 4g L square tan theta sine square theta. Now here is the point. Q is given, K is known, G is constant, L is given, theta is given, so I can find the mass M according to this equation. I hope this example help you to understand more about the electrostatic force, and hopefully you'll be able to solve these questions. If you have any more questions, please let me know during the online session. Thank you very much.